We'll get started right with this activity here. I mean, the last thing we were talking about was converting types. And if, of course, you went to the labs this week, you would have got, you probably would have got there if you were working through Caddis, maybe not quite there. But either way, here's an exercise. Work through this and do the calculation there. I'll give you maybe 2.5 minutes to do it, and then we'll carry on together. Okay, here's my working solution. Who here's done? Who here will be done in like 20 more seconds? Keep going, keep going, keep going. Isn't it funny how, like, in Canada, we like to pretend we use the metric system for our measurements, except we don't? Anyone seen that, like, flow chart? What unit do you use in Canada to measure things? It's pretty funny. It's like, temperature, okay, is it for cooking? Yeah, Fahrenheit. Is it for outside? Oh, it's Celsius. Is it a pool, though? Oh, no, Fahrenheit. How tall are you? Who here knows their height in meters? I don't know. You do? Weird. Mass in kilograms? No. I know how much I weigh in pounds. I don't know my kilograms. We're really bad at it. And here you go. And it looks like this person like genuinely made it in earnest. Like they weren't being silly. They were just confused. I can't open it, come on. This is very relevant to the course, right? So, all right, I for whatever reason, I can't zoom in very much, but point is, we kind of use the metric system when we want, and then we pretend we use it a lot when we don't, but anyways. So here's my solution. What did I do? Who here's solution looks more or less like mine? Does anyone have anything wildly different than what I've got? No? So here's what we were doing here. Is first I'm reading the input, and I'm saving in a variable called libs underscore string. Perhaps that's a little overkill, but I called it libs underscore string because it's the pounds, but it's a string. The next line, I'm converting it to a float, and then I'm just changing it into a variable called libs underscore float. Then I do the calculation, save it in a variable, kilograms, kgs, and then I print it out. Of course, I could have just done this, right? Let me just maybe. And it would still work. Did anyone do it like that? Yeah. I mean, hell, you can get fancy and just do like this. Or, I mean, why even save it in a variable, right? Just print. I mean, I could do all that in one line of code. Did anyone do it in one line of code? No? I mean, I just showed you various versions of the same code, right? I mean, it's doing the same function. Which one do you think I like the most? The one I did first? What makes you say that? Because that's the one I did. Yeah. You might remember me saying, let's make sure it still works. Code is for humans, not for computers. We have programs that translate the computer code to what the computer's like. But Python code is for humans to read. It's written by a human, so a human can understand it, for other humans to look at it and understand it. And then it can get converted to what a computer likes. This solution, I say, is the best of all the options because I can look at each line and each line is very descriptive. Each line does like one thing. It's straightforward, it's descriptive. Computer scientists are stupid. If a single line of code does too much, we can't keep track. It's too complicated. Keep it as simple as you can. You might think, but isn't it like better to have it in less lines? No, it's not. You could make that argument if this was like 1980 and you were really worried about the size of your files that you were saving because if it was too big, you didn't have the space on your computer and you're really worried about the total number of bytes you've got in your file. Today, we're not worried about that. So it really doesn't matter at all. If the code is descriptive, that's the best. In terms of what's efficient, all versions of the code that I wrote was probably converted to the exact same thing that the computer actually ran. The code was different, but the program that took the code and converted it to what a computer would like probably outputted the exact same thing, regardless of the versions I wrote. So in terms of, oh, it's more efficient, no, don't worry about efficiency. You don't do the efficiency. The program that converts it to what the computer likes will do that. What we mean when programmers talk about like what makes code good and whatnot, like efficiency, it's something entirely different that we will talk about a little bit later in the course. But right now, lines of code, they are not important. If your program is 50% longer than the person next to you, it does the same thing, but yours is easier to read, I like yours. It's not to say the other ones are wrong. Of course they were right. They're functionally the same. But self-descriptive code is what we like. Yeah?
Why did you make it a string first?
Well, I didn't make it a string. Whenever you read anything in, it's a string. input, no matter what you type, it reads it in as a string. So the fact that I called it libstir, that's just the name of my variable. I could have called it whatever I want. I could have called it and it's still going to work. Just the name of the variable is arbitrary. I mean, usually you pick a good variable name, and I thought one was libstir because its type was string. And that I didn't have a choice on that. It's just no matter what we read it as input, it always reads it as a string. Why? Because that's the way it is. I didn't write the input function. Someone else did. Take it up with them. Then I explicitly converted it to a float. Yeah. Good question, though, because I'm sure half the people in here are wondering the same thing. Other questions? That was a good one. Cool. Oh, look at that. We're done already. Now, functions. So scripts and programs, you know, we store them in files. I mean, you see them stored on Colab, but those are stored in files somewhere. And if you didn't know this, no matter what you do, on Google Colab, everything you do, like when you save it, it saves everything to your Google Drive. So don't worry, you'll never lose anything. It's saved to the cloud, right? Which is funny because someone tried once to explain like, oh, their computer died and they didn't have access to their Colab stuff. And I was like, oh, good news for you. It's not saved on your computer. It's saved in your Google Drive, which is, you know, the cloud. And then they had, oh. Turns out they were lying. They just didn't do it. But anyways, so at least don't use that excuse on me because I'll catch ya. But it saves it all there. So they are files. They're stored somewhere. And they're a great way to organize all your statements and expressions for your programs, right? It's a great place. Eventually, you're going to find yourself writing the exact same thing over and over and over and over again. Eventually. It's going to happen. And that starts to get really tedious. Or maybe if you're fancy, you'll copy and paste the code that you need to reuse over and over and over again all the time. All right? But it's tedious. It's prone to errors. And, you know, if your code becomes harder to maintain, and if you've got all this code that you've copy and pasted all over the place, and you have to make a change to it, you got to change it everywhere you've pasted it. It's a whole thing. So instead, this is where the idea of functions come in. So we like to group functionally related groups of sequences of statements together that serve a coherent purpose. We like to put them together in what we call a function that does the job. In Python and many other languages, yeah, they're called functions. So a function is going to be something like print. Print is a function. Input is a function. Type is a function. Those are all functions. If we go and we were to open up, like, look, you've been using the print function, but the reality is, if you were to take that function and open up the hood, you would see a bunch of lines of code in that function. But we didn't need to really worry about those, right? Someone wrote those, and we just called a function, and the function did what we needed it to do. It's great. But someone actually had to write that code. We can do the same thing. We can write our own functions to do whatever the hell we want them to do. We could write a function to convert Celsius to Fahrenheit. We could write a function to convert pounds to kilograms. We just wrote a couple of expressions, statements to do it, but we could turn that into a function. Why not? And another really nice good thing about a function that I'm pretty sure I will talk about as we go, that is often missed and forgot, is a function is a great way to give a name to some collection of statements. But we'll see an example of that maybe a little later to really hit the point. So function. Once you've defined a function, you can call it exactly the same way you call built-in functions like print. Now, listen up. There is a huge difference between defining a function and then calling or using the function. Who here has passed grade 10 math? Looks like most of you. That's good. Now, imagine for a moment I wrote something like f of x equals x plus 1. It's a very simple function. All that is the definition of a function. That's all it is. It just says, hey, if you give me an x, I'll give you back x plus 1. That's what it does. If I want to evaluate that function, that's when I show up and I were to say, oh, okay, so what's f of 3? What does that equal? 4. You got it. See, we're smart. What about f of 4? What's that equal to? What is it? Yeah, that's right. Right? So this is the definition, and now we're actually using it. Okay? The same thing's going to happen here. So if you've passed grade 10 math, the exact same thing's going to happen here. So here's an example chunk of code. Def, Celsius to Fahrenheit, temp in Celsius. And then here I broke the conversion down into multiple steps just because I'm lazy, I don't know. Partial conversion equals temp in Celsius times 9/5. And then temp in Fahrenheit is the partial conversion plus 32. And then at the end we see this return temp in Fahrenheit. That's the function. Who can tell me what it does? Convert Celsius to Fahrenheit. How'd you know? Because that's what it's called. But how do you, good thing it had a good name, right? Otherwise you'd be looking at the code going like, what does it do? No, look at that. Just like variables, we should have good names to give meaning to variables so anyone can understand. Same thing with functions. What does that function do? Well, it converts Celsius to Fahrenheit. Call it that. So now I look at that and go, oh, Celsius to Fahrenheit. I know what that should do, right? And I broke it down. Realistically, I probably would have wrote this in like 2 lines of code, not the 3 there, but whatever. So that does the calculation. And in the end, we see that return, temp in Fahrenheit. So here's the idea. First, actually, here we go. There's a lot to actually unpack here. Def. Let's start at the beginning. Def. That's a keyword for Python. Def. Who wants to take a wild guess what that probably means? Define. I'm actually not 100% sure. I've always assumed it's defined. I've never looked it up, but it's probably defined. So we're defining a function. And the name of that function, which we get to call it whatever we want, barring some rules of restrictions on reserved words and don't start with a number, whatever, just kind of like variables. But we can call it whatever we want. Here I called it Celsius to Fahrenheit. And then parentheses. And in that parentheses, I will have the parameter list. Some number of effectively just variables. That's really all they are. They're just variables. But these are variables that we're going to like give to the function. It's the same thing as this. This is the parameter, the x. So when I give you this, oh, x plus 1, that's what you do. But then when I actually use the function and go 4, well, what value does x take when you call it with 4 here? Come on. Go back to grade 10. Pretend you're in class. When you call the function f of x, and you say f of 4, what value does x take on? 4. Ah, there you go. Yeah. Right? Same idea here. So if I were to say temp in Celsius, because you know temp in Celsius is a hell of a lot better of a variable name than just x. If I say temp in Celsius 50, well, I want to convert the value of 50 Celsius to Fahrenheit. At the end of that top line, we've got that colon. Never forget your colons. If you forget your colons, it's not going to work, and Python will yell at you. And it might not even be that helpful in how it yells at you. But never forget your colons. Then you indent. Everything that is supposed to be inside that function, a part of the definition of that function needs to be indented. That's the rule. And then when you're done, you unindent. Let's talk a little bit more about it. So above is an example definition of a function that converts a temperature in Celsius to Fahrenheit. The details on all the parts will be discussed as we move through this topic. You can probably already sense that. One, it's a group of statements that serve a single purpose. I mean, there were 3 lines of code inside the function, 4 if you count that top line. But they all served a single purpose, convert that temperature. And it can be reused every single time I want. Here's what I'm going to do. I'm going to copy this, go here, nope. There. Nope. $32. Makes sense. Oh, what did I do wrong for parentheses? There we are. So what did I just do? I defined a function. Everything that's supposed to be a part of that function is indented under that top line. Then I called the function. But because, I need to take a step outside the function, I defined the function. I'm done defining, I unindent. That's why, I went back. And then I said, well, print out the result of calling Celsius to Fahrenheit on 0 degrees, then do it again, but on 10 degrees, and then do it again on negative 40 degrees. How many times did I define the function here? 1. How many times did I call it? Exactly. Very good. So calling a function. Given the function definition of Celsius to Fahrenheit, we can call the function, and there's several examples right there. My goodness, look at that. I also use the print function here. The print function was defined once, and I use the print function here 3 times as well. Right? I mean, I didn't write the print function, but someone defined it somewhere. Of course, it's always good to test all of your code, so we're going to test our functions like I just did there. It checks out from what I would expect. And so when you call a function, Python executes the statements within the function in the order that they appear, 1 line at a time, like all the code we wrote before. But be aware, though, it's probably a little easier to read. When I run this program, this is what Python did. It starts at line 1, and it goes, oh, we've got the definition of a function here. This is just the definition of a function. So I know I'm not actually going to run this code yet. I'm just going to be aware that this exists. And oh yeah, here's the contents of that function. Great. Oh, we're unindented. Carry on, nothing there. Carry on, nothing there. Oh, there. It gets to line 7. This is really the first line of code that's actually executed by Python. It says, okay, print, oh, the result of this. Well, what's this? Oh, that's a function. So we jump up here, and who wants to take a wild guess on line 7, what value did the temp in Celsius really is just a variable, but when they're used like this, we call them parameters. What value does temp in Celsius have right now? We just called that function on line 7. So what value do you want to take, would you guess temp in Celsius has? Someone yell it out.
0.
Why?
Because that's the argument.
Because I put it right there. And you, who said argument? Who said that? You? I'm going to quiz you for a second. No, that's a good thing because you used a good word. Why did you use the word argument?
Because in that instance, that's what you set it to when you're calling a function.
Yeah, so, okay, let me take a step back. So, okay, it's like a variable, right? Temp in Celsius is like a variable, and there, when it's there on line 1, we see temp in Celsius. Temp in Celsius, it's a variable, but when it's used like this, it's called a parameter because it's for the function. But the values that you pass Two functions are called arguments. And a lot of people kind of mix those words up all the time because it's kind of a bit of a nuanced difference. So I was really impressed when you used the word argument. So very well done. You should pat yourself on the back. Everyone give them a round of applause. That was wonderful. Holy moly. You should feel really good about yourself. There you are. So the values are the arguments, but what the variables are the parameters in the context of functions. That's really splitting hairs, though. If you ever mix up these words in class, I'm going to disown you as a student. It's a terrible thing, right? No, in reality, everyone mixes those up. It doesn't matter at all. Next time I call the function, what value does temp in Celsius have? And then how about the last time here? What value? Exactly. So I called it here with 3 different arguments, and then the parameter took on a different value each time it was called, depending on what the argument was. Functions are great because, one, it allows for reuse. How many times did I write all the expressions to actually do the conversion from Celsius to Fahrenheit? Once. But how many times did I call it? 3 times. Great. I can call it 1 billion times. It's great. It's going to work the same way every time. It makes it a lot easier to maintain the code. Imagine somehow we decide that we're changing how we convert the temperatures. I don't know why, but let's pretend maybe 2 years from now, no. We actually convert Celsius to Fahrenheit this way now. Okay, great. I only have to update the one function. And then every time it's called, it's fine. Right? What I mean is, if I had copied and pasted this code 1 billion times, and they decide, no, it's plus 33 for whatever reason, right? I'd have to go change all the 32s to 33s. It's kind of annoying. Where if it's a function, I only need to change it once. And every time I call it, it acts a little differently. But here's hoping they don't change that. And readability, like I said, Celsius to Fahrenheit is a lot easier to recognize when compared to something like the actual expression C times 9/5 plus 32. Unless you remembered, unless you were recently talking about the conversion from Celsius to Fahrenheit being 9/5 plus 32, if this was a year from now, you completely forgot that and you saw the line of code C times 9/5 plus 32, what is that? What is that? What does that mean? I don't know what that means. Or if a year from now you saw the line of code that said Celsius to Fahrenheit, you go, oh, it's converting Celsius to Fahrenheit. The name of the function describes itself. C times 9/5 plus 32, maybe you know what it means, maybe you don't. And more importantly, it facilitates abstraction. And we're going to talk more about this later, but this goes back to the idea that we talked about like the first day of class when I asked someone to describe how they made breakfast in the morning, right? Where I was playing that game of like, oh, how many steps do I take and whatnot, right? If you had a function that said walk to the fridge, okay, great, that does all the heavy lifting. How do we do that? I don't know, it's just defined in some function. And then you can end up having these layers of abstraction where you have less complex functions being used in more complex functions and more and more and more and more and more. And it's much nicer. Here I've been talking a lot. Go write a function to do literally anything you want. I recommend having it take a parameter and whatnot, maybe do something fun with it. But all you have to do is define it once and then call it several times and see what it does. Raise your hand if you're done. Raise your hand if it'd be done if I give you like 1 more minute. Okay, take the minute. Did anyone write a particularly ridiculous function for the sake of it? What did you do? It just keeps adding, yeah. Anyone else do anything silly? Just for the fun of it? Or you did, but you're not brave enough to say what you did? All right. So function parameters. So Celsius to, who here wrote a function that took a parameter, that had a parameter? Yeah, okay. So why do we have parameters? Well, we want our functions to be general. We want them to be usable in more general cases than single purpose things. It would be rather silly to write a function, if I wanted to calculate a temperature 20 degrees Celsius to Fahrenheit, it would be rather silly to write a function called 20 degrees Celsius to Fahrenheit. Because every single time it would return the exact same value, whatever 20 degrees Celsius in Fahrenheit is. That function's only ever going to have one purpose, and it's a really rather silly purpose. So what happens if I want to do it again, but for 30 degrees Fahrenheit? Write another function called 30 degrees Fahrenheit to Celsius? No. 30 degrees Celsius to Fahrenheit? No, that's ridiculous. What if I want to do it for 31 degrees, 31.25 degrees? I have to write a new function every time? No. Instead, we have parameters. Then we write the function where it'll work with any arbitrary value that we give it. Now here, this function only took one parameter. We could write functions that take multiple parameters. We could do whatever we want. We could have it take a billion for all I care. There probably is a limit. I don't know what it is. I never found it. But we make them take parameters to make them more general, like that. So if I were to write something like, yeah, 20 degrees Celsius in Fahrenheit, it would look like this. But this is useless. It's always going to return whatever 20 Celsius is in Fahrenheit. Let's see what that is. 68. Every single time this function's called, it's equivalent to just typing the literal 68. That's dumb. it's not helpful. So we make it have a parameter, so we can give it an argument to do the calculation. If it helps, like I already said, just think of it as a variable. But where in our code, when we typically assign variables, like a equals 5, here we assign the variable just by calling the function. Celsius to Fahrenheit, 5. There. When I call it like this would be like saying temp in Celsius equals 5. So I'm doing the assignment in those parentheses when I give it as the argument. Now, you've already been using arguments with print. The thing you're printing out, you give as the argument. The value you put in the parentheses for that print function is the argument. And what's cool about print is you can actually add an arbitrarily many number of arguments to the function. That's what the commas were. You can actually just keep adding more arguments, and it'll print them all out. It just spaces them out by one. And, like I already said, if this is making you scratch your head, you're thinking too hard. I've said it before, I'll say it again. Chances are, remember, programmers are stupid. Early programmers, new programmers, when you're just learning, one of the common mistakes people make is thinking too hard. Thinking it's got to be more complex. No, it's not. Programmers aren't smart enough to think that hard. It's the same as math. Like I already said, if we had the function f of x equals x times 9/5 plus 32, that's the definition of some function. Then if I want to know what f of 20 is, I can do the calculation. 68. Here, if we use the programming words that we're using, is okay, 20 there is the argument. X is the parameter, right? We give the argument to the parameter, and then parameter, we do the calculation. And then when we're done, we get back the result. It's the exact same, except here, we use the Python syntax, not the math syntax that you've just been using since you were this big, right? Any questions about anything up until now? Ask now, because I'm bored and I don't want to talk anymore. I want a break. Yeah?
You said you can put like 2 arguments with one argument. When I try it, it gives me error that says it only takes 1.
So, I'm going to show you what you did, right? So Celsius to Fahrenheit. You did something like this, right? And then it was like, well, hold on. It takes 1 argument, but 2 were given. Yes. This will work if we defined the function to take 2 arguments or have 2 parameters. But here, ours only took 1. So let's just write another function for the sake of it just right now to show you an example. Def some weird A, B, C, return A plus B times C. There. And then print some weird function, 1, 2, 3. There. Great. So now I was able to give it 3 arguments because that function was expecting 3. So we can do as many as we want as long as it was defined to take that many. Now, if I show up and I try to give this one 4, it's going to say, well, no, it's expecting 3, but you gave me 4. Or similarly, I gave it less, missing 1. The argument C, right? Because I gave it the A and the B. Now here's a quiz for you. And remember how stupid computer scientists are. Oops. We've got 3 parameters and 3 arguments. But which one goes where? It's all positional. The first one goes to the first one. then the next one goes to the next one, and so on and so on and so on. It is just that simple. If it was any more complex, programmers wouldn't be able to do it. Great. Now the return. Now we'll talk about return in a moment. I don't want to get ahead of myself. The execution of the function. So below is a simple and arbitrary function, square of sum, that takes two parameters a and b and calculates what the square of their sum is. So a and b. First it does a plus b, stores it in the variable c, and then it just does c times c to effectively square the thing, right? C times itself. Store it in a variable d and return d. There, done. Great. If I were to call this function, now remember, this is just the definition. It hasn't been called yet. If I run this program, Python will do no execution. There's no number crunching taking place. Let me be clear on what I mean. I'm going to take this code. I can run this, but nothing is happening. Because it's just the definition. Python keeps going like, thanks for telling me. I understand, that's the function. But I didn't do anything with it. When I call the function, for example, square of sum 2, 3. Let's go down here. Nope, whatever. We see 25. Now, I already had warned you. If it was something like this, first of all, this wouldn't work for various reasons. But this, if square of sum was indented, that would mean that that statement is a part of the function definition. But we don't want it to be, so it's unindented. Oh, pardon me, print the result. I know it showed the 25, but did I print out 25? Who remembers? No. What happened was it just did that thing where there was this floating, dangling value of 25, and Colab was just like, oh, there was a 25 there. But I didn't really print it out. Was your hand up, or were you just like stretching? Ah, perfect. Nice. Yeah, so now I'm printing it out. I know it looks like it's doing the same thing. It's not. And just to prove that point, how come no 25's printed anymore? Because I never printed it out. But if I do this, it's there, because I actually printed it out. So, what's actually happening? Well, when I call the function, first thing Python is going to do is check, am I aware of a function called square of sums? If it is, yeah, it's happy. If it does exist, it'll go, okay, great. It takes the values supplied to it, the arguments, 2 and 3, and assigns them to their respective parameters. So effectively, in this particular example, calling it with 2, 3, a becomes 2, b becomes 3. And the reason it's not the other way is because that would be weird and confusing. The first one goes to the first one, the second one goes to the second one. Then, the sum of a and b is calculated and put into the variable c. The variable c is multiplied with itself, squaring it. And the result is assigned to the variable d. Then the function returns the value associated with d. If you provide too few, it'll yell at you. If you provide too many, it'll yell at you. And there we go. Now, like I said before, when I ran this cell, it goes, oh, okay, there's the definition of a function. Great, I'll remember that. Line 6 is the first one that actually does something. So, sum of squares is called, it gave it 2, 3. Who wants to be, I need a volunteer. You don't have to say anything, you just have to pretend to catch something and throw something. Perfect. Okay, your sum of squares. I'm going to give you 2 and 3. Okay, you ready? Okay, here's a 2. Good catch. Here's a 3. Great catch. Okay, now you're going to do your number crunching, and you get back, after your number crunching, you've calculated it to be 25. But you have the 25. You're the function. I called you. I don't have that 25 yet. You've got it. So what you have to do is you got to give it back to me. So return the 25 to me. Just pretend to throw it. Perfect. Great. Now I have it. So when I gave you, That little function kind of acts as a little computer program in and of itself. It takes input and it produced output. You're waiting for input. I gave you an A and a B, you did something, and then you gave me back something. In order for you to do this calculation with A and B, I had to give it to you. And in order for me to get back the result, you had to give it back to me. So the parameters, that's where the arguments and parameters is where I give the function information, and the return is where the function gives information back. So when I called this line of code here, sum of squares 2, 3, effectively evaluated to the value 25, because that's what the function returned when I gave it the parameters. A is 2, B is 3. So what gets printed out? The result of calling that function. If it makes it a little bit more clear, there. I called sum of square. The value 25 is returned, so it gets put into this variable, and then I print that variable out. So the arguments, parameters are how we give input to the function. Return is how you give information back. I'll end with this. Some people do this. First and foremost, as a rule of thumb, never, ever, 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 ever use input or print inside your functions. If you want to use input in your code, do it before a function call. Maybe you read in the input, you parse it, and then you give the function the inputted data. And never, ever, ever print out something from your function. Get it returned back and then print it out. As soon as you start doing I/O, these are things that are called like side effects. As soon as you start doing I/O inside your functions, it's a recipe for disaster and mistakes. We'll pick up there whenever the next class is.